All right, so first of all, let's talk about maxes, mins, and intervals of increase and decrease.
Mr. Bailey, can I get a cup of water?
Of course.
Over
There.
Where? Oh.
You'll probably have to write that somewhere else, right? Because that front page I printed for you doesn't have a space. So, okay. So, if we have a parabola, you guys, it looks like this. This point right here would be our maximum. It's a y value. So when we talk about maxes or mins, we're talking about the highest point or the lowest point. So in this case, that top point would be your maximum. If your parabola was like this, then you don't have a maximum because it just goes up forever. There is no maximum value. It just keeps getting higher and higher. But it does have a minimum value. So it all depends on which way your parabola is going. Now, if you guys have a different colored pen or a highlight or something, you might want to have that. I might help you here. I'm going to do some. If not, it's okay. You could probably still label it without it. But I'm also going to show you guys some intervals of increase and decrease. So here we go. The minimum and maximum point is a place where the graph goes from either increasing to decreasing or decreasing to increasing, one of the two. So when you look at functions, we always go from left to right. So let's start on the left. As I move towards the right, would you say I'm increasing or decreasing?
Increasing.
Okay, so this is what we would call an interval of increase. Okay? But what happens after the max? It starts to decrease. So on this interval, it's decreasing.
Wait, where do we put the color code?
Just like I'm doing.
Oh,
Now when it's the other kind of parabola, we'll label it the other way. In this case, what's happening on the left? It's decreasing, right? And what's happening on the right? Now it's increasing, right? So that's what maxes are and mins. It's the highest point and the lowest point on a parabola, or any graph for that matter. And it's also the place where a function changes from being an increasing to decreasing, or vice versa, decreasing to increasing. Okay? So the first thing that we're going to do today is we're going to look at a function and we're going to identify what is the minimum and what is the maximum. We're also going to talk about what are the intervals of increase and decrease. Now, as a little note down here, you might want to write this little note. Ready? Maxes and mins are y values. I already said that, right? But the intervals, we're going to give the intervals in terms of x. And it's going to look like that. So in other words, we're going to say this function is increasing on the interval from x equals blank to x equals blank. Okay? So intervals are going to be in terms of x, but maxes and mins are going to be in terms of y. I'll pause because get out that worksheet that I printed for you guys, and let's all find this example here. It's hard to read the writing, but the good news is you have it right in front of you. You guys see that example on your paper? Okay, so I would like you guys to tell me, does this function in this picture right here on the bottom left, does that function have a maximum value or a minimum value?
A maximum because it goes up.
Minimum.
It has a minimum value.
What?
Right here.
Oh.
Now, remember what I told you? Minimum and maximum values are what kind of numbers? X's or Y's?
Why?
So what's the Y value there?
1.
The Y value is 1. So here's what we're going to put for this. It has a max. Oh, I'm putting it in the wrong spot though. This is max. And what is the value of the max or min? Y equals 1.
He has a max.
Oh, I'm sorry, minimum. My bad.
Wait, how do we know if it's max or min? I'm sorry.
From the picture you drew down earlier. Look at your picture. All right,
I don't hate to be the person, but
Be the person.
Credit point for that.
yeah, I will get you an extra credit point. You should be that person. Okay,
Yeah, you should.
now,
Okay.
this part's a little bit confusing, so make sure you guys pay close attention here. I think we're going to look at what are the intervals of increase and decrease. Pay attention, guys. Okay, so on what interval is the function increasing? Do you guys agree that starting here and up, it increases? Okay, so we need to identify the interval. Henry and Fonjane, you're not. It's the second time I talk. You're gonna miss it. Ignore him. All right. So we want to identify the interval in which this is increasing. Now I've highlighted it in purple here, right? So now I told you guys intervals were x values, right? We're looking at an x range here. So what's the x value? What x value does it start at? I can't really tell. It starts at 3. Okay. And after that, it just keeps going to the right forever, right? That's our interval of increase, from 3 on up to infinity. Okay?
Why don't we put the less than equal?
Because it can, I guess, you know what? Maybe we don't put the equal there. It doesn't really matter. I wouldn't stress about it too much, but, huh?
B says ID equals 1, right?
No, B says y equals 1. All right. Now, on what interval is the function decreasing? Well, that's everything to the left. Don't you guys agree? Okay, so how would I write that? Well, it's on the left. How far to the left does it go? Infinity. So we're going to put negative infinity. And it stops decreasing when I get to what? 3. And x is going to be like that. Okay? So what I just did was I did example 1A through D. I want you guys to go down right underneath of that to students practice 1A, and I'd like you guys to do A through D.
Wait. Oh,
Actually,
Yeah.
what did that mean? Divide the y-axis. Is it something you divide the y-axis? You don't have to check this since it's on the y-axis. Do you have to check or no?
no. Yeah, that shouldn't affect anything. All right, so Gabby, does this graph have a min or a max? Good? Henry, what is the value of the minimum?
Y equals 3.
Very good. It's right here, right?
Yeah.
Okay. So if I were to ask you guys to come up here and trace the interval of decrease. Kayla's not here today. It's very sad. Natalie, can you trace the interval where it's decreasing for me? Thank you. Great, thank you, ma'am. So we all agree that it's decreasing from here and up to there, right? So now we're going to write where it's decreasing. That would be part D. So I'm going to ask for part D. I'm going to skip C for now. Javier, what did you get for the interval of decrease?
Negative infinity. The less than x.
Close. So it has to be so 3, that's the y value. What's the x value?
0.
0. So it goes from, so it's decreasing from negative infinity to 0. And so now we're going to go ahead and trace the rest of it, which is the interval where it's increasing. So let's talk to Rowan. On what interval is it increasing?
0 is less than or equal to x Wait, no, just what?
Yeah, you don't need the equal to's, but that's fine. So this one starts increasing at 0, and then it keeps increasing up to infinity. So there's your intervals. Okay? So that's maxes, mins, intervals of increase and decrease. I think, you know, the most common mistake I've seen as I went around was people that we put the y value for the interval, but we remember it was the x value. Okay? Yeah. I'm teaching right now. Is it just something you can say to me real quick? Okay, do you need to go to the bathroom? Or something? Okay. Yeah, we'll chat in a minute though. Let me get to our next student practice. So I'm going to back up here to this example here. It says 1A. Let's go ahead and take a look at example 2A now. So go back to the very first picture that we had on our notes today. Same picture. We're gonna answer that question now. Okay, but before we do, we need some more notes. So let's chat a little bit. Part B. Write this along with me somewhere on a separate sheet. Average rate of change. Also known as average slope. Also known as average slope. You gotta go somewhere? Where are you going? They have to call.
That's why.
Well, I can't let you go unless they call. No matter what, so they have to call. All right. So I don't want you to draw the picture I'm about ready to draw. I just want you guys to pay attention. We will draw a picture, but not this one. We talked about linear functions before. Linear functions look like this. Linear functions always have the same slope. Over 1, up some. Over 1, up some. Over 1, up some. Look at these heights. They're always the same. Every time I go over the same amount, the height is always the same. It never changes. But when you're talking about a parabola, that's not true. Like from here to here, look at my height. But if I go over the same amount, now look at my height. It got steeper, right? And then it gets even steeper after that. In fact, it's so steep I don't even reach it at this point. So the slope of a quadratic function is constantly changing. So you can't really say the slope of a quadratic function is, there isn't a slope. It has an infinite number of slopes, so it's constantly changing. But what you can do is you can find an average slope. Okay? An average slope is what you would get if you picked one point on your curve and another point on your curve, and just imagine a straight line connecting them, and you found that rise over run. And that tells you your average rate of change, your average slope. Okay? So now we will draw a picture. So let's go ahead and draw a picture. Let's go ahead and draw the one we just had there. So let's say that we have a function, f of x equals y. Let's say that this x value is A. How would I find out what the y value is? You would plug it into the f function. So we'll call the y value f of A. I would, yeah. I think it'll be helpful. Let's say that this x value was b. What would this y value be? F of b. Do you guys remember the slope formula? y2 minus y1 over x2 minus x1. Instead of using y2 minus y1, I'm going to use these though, okay? So the average rate, or average slope, we'll say, the average slope is y2 minus y1 over x2 minus x1. It's just the slope formula, but I'm writing it a little bit different than usual. I'm writing it with function notation instead of...
Does it have to be B then A, or can it be F?
So you could do f of A minus f of B, but if you do that, then you have to switch these two. So if B comes first here, B comes first here, they have to match in that way. Otherwise, you'll get a backwards answer.
Which is like when we find normal slope.
Yep, exactly. There's really nothing different. I'm just using different notation. I'm just using different notation. Bless you. Okay. Yeah, let's chat for a second while they're writing. That would mean your function's decreasing on that interval. It's possible that you get a zero slope. And in that case, that just means your line is flat. Okay? So on that interval, basically it didn't go up, it didn't go down. Maybe it did go down, but then it came back up and it landed basically at the same height. So it looks like pretty much no change happened. Okay? So that would be something else to keep in mind. Okay, so let's go ahead and go back to that example now. Does anybody need this still? Yeah, I'll wait a little. Okay.
What the heck? You hear my voice?
I did. It was interesting. All right. So I'd like you guys to find example 2A. Do you guys see example 2A? Very first picture on the top left, example 2A. Okay. I'm asking you to find what's the average rate of change on the interval from 4 to 5.
1.
Now those are x values, aren't they? So let's go to our graph, and I'm going to highlight where x is 4 to x equals 5. You got it? That's going from 4 to 5. Now let's go ahead and we'll do our formula. What is this point right here?
Which one? Sorry.
4, 2.
Yeah, 4, 2.
And what's this point? 5, 5?
Yes, sir.
Okay, let's find the average slope. Now it doesn't really have a slope because it's constantly bending, but we can find an average slope that gets pretty close to what we could say that the slope is on average. So you guys ready? It is. Ready? y2 minus y1. Let's call this x1, y1, x2, y2. What's y2? Minus y1
Yeah. Wait, what? You mean 5?
over x2
4
over
minus 5.
5. All right, that ends up being negative 3 over negative 1, which is positive 3. That's our slope. That's our average rate of change. Yeah. Is the problem we're working on right now? We're right here. All right. So let me ask you guys a question. On this interval, you could tell just from the picture, is it increasing or decreasing? Why is it increasing? You could tell from the picture because it's going up. How can you tell from this? It's positive. Okay? So we're going to do one together here real quick. Thank you. All right. Can you guys please find example 2B? It's right next to it, to the right of the problem we were just on. Do you guys see example 2B? Okay. Here we go. The first thing I want you guys to do on example 2B is I'd like you to highlight the part of your graph where x goes from -1 to 0. See if you can highlight the part of your graph where x goes from -1 to 0. Remember, those are x values, right? From -1 to 0. So we should have highlighted the area from here. That's where x equals -1, right? To here. So we want to find the average slope on that interval. Now, let's go ahead and name these points. What is this point? -1, -1, right? And what's this point? Okay, let's go ahead and call this one x1 and this one y1, x2, y2. Go ahead and see if you guys can find your slope and then tell me if it's increasing or decreasing. I'll pause for like a minute and a half. So there's our answer. Let's go ahead and do one more. All right. So for student practice 1A, I'm sorry, 2A. I want you guys to find student practice 2A. That's the one on the bottom left. Do you guys see the picture on the bottom left? I want you guys to do student practice 2A. I want you guys to highlight the section of your graph that has this interval. I want you to find its slope, and then I want you to tell me if it's increasing or decreasing. I'll give you a few seconds. So we're going from 1 to 2. That would be from here to here, right? And yeah, you're right. It does come out to be 3 again. That's kind of irritating, but oh well. So we have 1, 4, 2, 7. If you do your slope formula, you get 7 minus 4 over 2 minus 1, which is 3 over 1, which means my slope is 3 once again, the average rate of change, and it's increasing again because it's going up. Okay? So that's that. We have one more example I want to do. So today we've looked at mins and maxes, intervals of increase and decrease. We've looked at average rate of change on a graph. Now we're going to do average rate of change, but without a graph. We're going to do it with just an equation. That's our last thing we're going to do. Do you have a question, Javier? No? Okay. Last thing I want to throw at you guys for the day. Ready? Example 3. Write this down with me. Y equals 2x squared plus 1. What? You're a horrible student today, sir. You're being a horrible student. I'm going to tell you that. I'm telling you. Find the average rate of change on the interval. Give me an interval, Henry.
2.
Well, that's not an interval, but we can start there. Give me another number. Don't make it too big, though.
Bigger?
Yeah.
Like 7.
All right, 7. So we want to find the average rate of change of this function on the interval from 2 to 7. But we don't have a picture this time. So how are we going to do it? I'll show you. What?
I don't know, the way you said, I'll show you. It's just funny.
It was inspiring, wasn't it?
I wouldn't say inspiring, but
All right. So, you guys ready? It's not bad. There's a lot of steps, but it's not hard.
Like, is it simple steps?
I think so. All right. Step 1. Ready? Find the y's. Find the y's. Because I've already got my x's, right? We're starting at x equals 2, and we're ending in x equals 7. I've already got my x's, right? So let's write that. X equals 2, x equals 7. Let's write both of those at the top. So what I want to do is I want to find out what is the y value when x equals 2. How can you find the y value when x equals 2?
So x would be 0.
I don't know about that. Okay, I'm gonna give you a hint. How can you find y when x equals 2? Yeah? That's it. You plug 2 into your equation up here. So, here we go. Y equals 2 times 2 squared plus 1. Follow your order of operations. What do you do first?
So it'll be 2. It'll be 4 squared. Oh, never mind.
You do that first, right?
2 times 4. So it'll be 9. Like
Yep. So, when x is 2, y is 9. There's your x1, y1. Let's repeat that over here. Now I want to find what is y when x is 7. So this is going to be 49, right?
yeah.
49 times 2, that's a pretty big number.
It'll be like 90 or something. Wait, no, I did that.
99.
It is 98. Oh, it is 99. My bad.
So that's step 1, guys. Just plug in the x values that they...
Step 1.
Yeah. Plug in your x value to get your y values. Okay? Do I have an x1? Do I have a y1 to go with it?
Oh,
Do I have an x2?
Yes.
Do I have a y2?
Yes.
Do I have enough to get a slope?
Yes.
Do. So step 2 is just to do your slope formula. Okay? So let's call this x1, y1, x2, y2. You guys ready? Yes, Mr. Bailey. In fact, we're excited.
Wait, look at that.
No.
that one kid in the bathroom. I mean, the back.
So, yeah, of course you can. What's y2?
99.
Minus y1
9.
over x2
7.
minus x1.
2.
90 over 5, 18.
15.
Somebody already got it? 18?
Oh, yeah, it's 18, my bad.
There's your slope. That's pretty steep.
How did
That's
you-
over 1 up 18. That's a pretty steep slope. So this is step 2. Might want to write that down. Step 2 is y2 minus y1 over x2 minus x1. There you go. Not too snabby, no?
Well, you need to see.
So step 1, find your y's. Just plug it into the equations. Step 2, slope formula. Bueno?
See.
Good. All right, I'm going to give you guys one.
I say this is easy, and then you give us one that we all get confused, and we're all screwed. That's how it is. Yep, exactly what I just said. We're all screwed.
All right. I would like you guys to find the average rate of change on this interval. Go for it. We have two x values. The first thing we need to do is we need to find our y values. So what did you get when you plugged in 0? Got 0? It's a good try, but I'm afraid it's not. 15 sounds good. So I'll show you why. If you plug 0 in for x, do that first. 0 and 4 make 4. 4 squared is 16. And 16 take away 1 is 15. Yeah. What? Okay. Let's do Nathaniel.
Yes.
When you plugged in x equals 1, what did you get?
I got 24.
24 is good. One plus 4 is 5. 5 squared is 25. And 25 take away 1 is 4. Okay, so I'm going to call this set over here x1, y1. I'm going to call this set over here x2, y2. And then I'm going to ask Jonathan, what'd you get for your slope?
9.
9 is right. Because y2 minus y1
Equals 9.
over x2 minus x1
So equals 9 over 1. Comes up to 9.
is 9.
9 is increasing.
And it's increasing, right? Why is it increasing?
Positive.
It's positive. Henry, I'm going to have to move your seat, but you're not going to sit there anymore. Just so you know, next time that won't be your seat. Bro, you don't know how to pay attention.